All right, so if you've read the first part of your lab, you know that we have a bit of a mystery here. There's 4 people, John, Andrea, Marlene, and Daryl. John and Andrea have come into a lot of money they didn't even know that they had, and they want to leave it all in their will to their daughter, Marlene. Daryl has apparently found out about this and claims he is the long-lost son of Andrea and John and wants some of the inheritance. Well, there are many ways to figure out if Daryl is in fact their son. One way is through a blood test. Now, this blood test could prove for sure he's not their son, or it could prove that he's possibly their son. Just because you have the same blood type or a blood type that would match John and Andrea doesn't mean he's automatically their son, but we could definitely prove if he's not their son. So that's the mystery we're going to solve. And in order to do that, here's some blood from each person. So got some blood from John and Andrea and Marlene and Daryl. And these are the little trays where we're going to test the blood. So if I take some of John's blood and I pour a drop into each well, and there is a place for A and B, because what we're going to do is test to see if the blood is type A or type B, which will also let us know if it's type O. And here's Daryl's blood. If you're wondering why there's an extra little well that we're not using, that would be for the rhesus factor, if the blood was positive or negative, which we're not testing for in this, because blood type can be, you have the ABO or AB, and then also a positive or negative, but we're not dealing with the positive or negative today. So with John's blood, here is the anti-serum for B. So I'll put a drop of this in each person's B well. This will show us if they have the antigens for B, the B antigens in the blood. So if basically the blood kind of clumps or does what's called coagulation, then we know that it is in fact that type of blood because it has the antigen. So I'll put a drop in each person's well and mix it up a little bit. And I'll use a different end or a different toothpick so that there's no contamination. And it'll take about 30 seconds before we see the results. And I'll do the same thing for the A. This will tell us if there's A antigens in their blood or not. And mix. Now, it doesn't look like much has happened right away. So they've sat for just a few seconds, and it's hard to see just from here if you have any of the kind of clumping. So if I lift this up to the light and move it around, now you can see that in the B well, there is this clumping that's happened. So for Daryl, he does have B antigens on his blood. So in your chart, for Daryl, for the antigen A, no, he did not have any. But for B, yes, he did. Now, if we check out Marlene, kind of working backwards here for some reason. Marlene, nope, nothing clumped in her blood at all. So she's no for both. Andrea, get it to move there. Okay, there you can see that Andrea's got some clumping in the A well. So yes for the A antigen, but no for the B. And then John, he also has nothing in either one. So this gives us the information that we need to basically figure out their blood type. If John has no A antigens and no B antigens, what would his blood type be? You're correct if you said blood type O. O is the blood type that has no antigens at all. Andrea has A antigens, no B antigens. What is her blood type? Correct, it's A, because she has the A antigens. Marlene has no antigens at all, so she is an O. You can fill in what Daryl would be, and then we're going to go on to the next page. First, I want to look at the genotypes for blood, because when you guys watched the video yesterday, this is how the genotypes were written for blood. And this is how you'll mostly see genotypes written for blood. This is kind of the official way, but it's more complicated than we perhaps need at 8th grade. So if it makes it easier, you can simply represent them with the letter types. So if you're type A blood, you have 2 possible genotypes, but you could also write it as just AA or AO. If you are type AB blood, though, because blood type is codominant, you can be AB. That heterozygous genotype gives you a mix. So you have A antigens and B antigens. It's a pretty rare blood type. For B, you can either have 2 alleles that are for the B antigen, or 1 allele for B antigen and 1 not, which still gives you B blood, because the O is like it doesn't exist. And if you are 2 little i's, that's the same as saying you're 2 O's. So you are O blood type. That's the only way you can be type O blood type, is if you have the 2 antigens that, or the 2 alleles for O, which is the coolest blood type because it's mine, but I digress. So, getting back to what blood types you'll write down here for John's genotype, you can write it down then as the 2 capital letters, whether it's AA, AB, OO, whatever you have discovered John's genotype is, and Marlene's genotype. And we can tell by the test we just did. What we can't tell is what is Andrea's blood type. There's 2 choices. But since we know John and Marlene's, we can figure it out with a Punnett square. This is where John's blood type is going to go, and this is Andrea's. We don't know for sure what Andrea is. We know it's A something. We don't know if it's A or O, though. But we know John is OO, and we know their daughter Marlene is OO. So if Marlene is OO, what does Andrea have to be? What letter has to be here in order to make this possible? Has to be O. So Andrea is AO. The next thing you need to do is fill in the Punnett square to show the possible genotypes then for Andrea's children. So if Andrea is AO and John is OO, what are those possible genotypes? From here, you should be able to finish the lab on your own.